Everyone, welcome back to another lesson in Unit 6. Mr. C here. I'm hoping you're all having a fantastic day. We are going to jump right into target 6B. Day 1, we're going to start adding and subtracting polynomials. So, as always, we got to make some definitions first before we actually go into the computation and some of the problems. So, earlier this week, we were talking about monomials. Remember, monomial was a one-termed expression that was a product of numbers and variables with positive exponents. Now we're going to be starting to talk about polynomials, and poly means many. So a polynomial is going to be a monomial or a sum of monomials. So I gave a couple of examples here. I've got 5x, 2x squared plus 7, and x cubed minus 10x plus 1. Each of these is a special type of polynomial. So you'll notice in 5x, you only have one term. So that's the monomials that we talked about earlier this week. Monomial. We've also got 2x squared plus 7. I have two different terms here. Two different terms. I'm going to call that a binomial. And then last but not least, I've got three different terms here, and that's called a trinomial. These are just some math-specific words that are going to be helpful as you go through your math career. So let me scroll down and get to some other definitions. We've got a degree of a polynomial. The degree is the greatest variable of any term in the polynomial. And we'll look at some examples so you can see what I mean by degree. So I can tell you right off the bat in our binomial example up here, this 2, that would be the degree of the polynomial. I've also got something called standard form of a polynomial, and this is how we are going to want to list our polynomials. When we write a polynomial, we want to go in order from greatest to least degree. So we want to write our polynomial in order from greatest to least degree, or greatest to least variable. So we want to go to the highest variable to the lowest variable. And remember that constant terms have a degree of 0. I added that up here. So in these three examples that I have in your notes, those are already written in standard form. And last but not least, we have a leading coefficient. Leading coefficient is the coefficient of the first term of a polynomial in standard form. So, in our monomial example, 5, that would be our leading coefficient. The binomial, 2, would be the leading coefficient. And in the trinomial, there's this 1 here. 1 would be the leading coefficient. So, that is going to knock out all the vocab for this section. Let's get into problems actually using it. You have this chart in your notes, and I think it's a little faded, and I apologize for that. I don't really know what happened there. But understanding this chart and knowing these vocab words is going to be very important. So we list what the degree is. Once we figure out what the degree is, we know what type of function we're dealing with, whether it's a constant function, a linear function, which we spent a lot of time with last semester. Quadratics are going to be very big this semester, and as you go on and on, these are just some special names for polynomials. And then, number of terms determines what type of vocab word I'm going to give to the polynomial, whether it's going to be a monomial or a trinomial, something along those lines. So mono means 1, bi means 2, tri means 3, and anything that has 4 terms or more, we don't have a special name for it, we just call it a polynomial. So, enough of that jargon. Let's get into using it. So, for our first two examples, we want to determine whether each expression is a polynomial or not, And if it is, I want to write it in standard form, find the degree, identify the leading coefficient, and classify it. So, in A, this is what we're starting out with. Well, I don't see any variables in the denominator. I don't see any negative exponents. This looks like a polynomial, so it is a polynomial. In standard form, I want to write it from highest degree to lowest degree, and so I'm going to have the exponent 3. That has to be first, so that term's first. Next is 2a, and then last but not least, I have minus 1. So once I get it into standard form, then I can start listing all of the other vocab words. The degree of my polynomial is 3. The leading coefficient is negative 4. And the classification, well, its degree is 3, so that makes it a cubic. And I have 3 terms, and that right there is a trinomial. So here I've got a cubic trinomial. And so that knocks out example A. Let's look at B. Do I have a polynomial here? Well, if you notice, you have a negative exponent and you have a variable exponent. Both of these are not allowed. So I don't have a polynomial, therefore I can't fill out anything else with that. Okay? So it's very important that you go back and you understand this chart, these different vocab words, because we'll be using that a lot, not only in this class, but also the classes you go on to in the future. To the meat of today's lesson, we want to talk about how to add and subtract polynomials. The main thing that we want to do when we're adding and subtracting polynomials is to combine like terms. I want to combine like terms. So, for example, I've got 7y squared plus 2y minus 3. That's my first polynomial. And I'm going to add to that 2 minus 4y plus 5y squared. So, the highest degree here is a degree 2. The highest degree here is also degree 2. So, I am going to add those 2 terms first. And I find it helpful to underline my like terms. So I get 7y squared plus 5y squared. That's going to give me 12y squared. So I'm done with those now. Next, I've got just my y's, my linear terms. So I get 2y plus negative 4y. That's going to leave me with negative 2y. And that takes care of those. And then last but not least, I have my constants that I need to take care of. I got negative 3 plus 2. That's going to be negative 1. My polynomial is in standard form. So there's nothing else I have to do to rewrite it from here. That's my answer. That's the sum of those 2 polynomials. What about subtraction? What do I do here? Well, it's very similar, but the first thing I notice is that I'm subtracting this entire polynomial. So what do I have to do with this minus sign? I have to distribute it to each term. And that's going to make it an addition problem. So what I'm going to do is I'm going to copy down the first polynomial, leave everything the exact same, and then I'm going to distribute that negative sign. So I've got minus 9y to the 4th. Here I've got negative times negative 7y, so that's plus 7y. And then I've got negative times 2y squared, which is going to be minus 2y squared. Once I get that, then it's just a simple addition problem. Just combine like terms. So let's look here. We got 6y squared. Do we have any other y squareds? Right here. So I get 6y squared minus 2y squared. That's going to give me 4y squared. And then next I've got a y to the 4th. Do I have any other degrees of 4? Right here. Anywhere else? Nope. So I got 8 minus 9y to the 4th. So that's minus y to the 4th. That takes care of those. I've got a negative 5y. Do I have any other y's? Right here. So I got negative 5y plus 7y. That's going to be plus 2y. So our adding is done, but we want to make sure that our polynomial is in standard form. So we want to make sure our highest degree is first, and that's not quite what we got yet. So I'm going to rearrange this. We have negative y to the fourth plus 4y squared plus 2y. And then this would be a quartic, because my degree is 4, a quartic trinomial. So that is the main lesson for today, and we are going to close it out with an application problem. So, from 2006 through 2016, the number of dogs and the number of cats in hundreds adopted from animal shelters in the Chicagoland area are modeled by those two equations. These are going to be important. Those two equations, where n represents the number of years since 2006. So, my first question is, I want to write a function that models the total number of dogs and cats for this time period. So I don't want to just talk about dogs or cats, I want to talk about the total. So what do I have to do with these two underlined equations to find t? I have to add them together. So I've got the total is going to be represented by the number of dogs plus the number of cats. Then all I have to do, combine like terms. 2n plus n is 3n. 3 plus 4 is 7. So that's my function, and that is what I'm going to use in part 2. 2 is asking if this trend were to continue. So if this growing continues past 2016, is that how far this? Yeah, if this trend continued past 2016, how many dogs and cats will be adopted in 2020, next year? So, n, what did n represent? And I'm going to make this small real quick. N represented the number of years since 2006. So if I'm talking about 2020, how many years since 2006 in 2020? Well, that's 14 years. So what am I going to do with that 14? I'm going to plug it in for that n. So to find the total number of cats and dogs in 2020, I'm going to plug in 14 for n. And then I'm going to use my calculator to simplify that down. And I get t to equal 49. But remember, my expressions represented the number of dogs and cats in hundreds. So, if I were to write a complete sentence, in 2020, 4,900 dogs and cats will be adopted. And that's good news. Everyone should adopt a dog or a cat. Alright? So, that is today's lesson. I hope you learned something. Make sure that you are taking down these notes, you are asking questions, and make sure you do these You Try Now so you can get some credit. Now, I did underline over here for part A. I changed that polynomial. It's a little different than it is in your notes. It's a little bit easier. So make sure that you copy down the one up here on the screen right now, and don't do the one that's in your notes. That's what we will go over tomorrow when we go over this lesson and we use class time to work. So don't forget, take your notes, ask questions, make sure you're doing those Alex topics. And as always, be safe, be good, do some good. I'll catch you guys later.